All right, so this is going to be my video for project 1 in design of aerospace experiments, creating the 2D wind tunnel. I've already got Ansys Workbench opened up, so we're just going to get right into it. I'm going to drag out a fluid flow project and throw it right in there. And we're going to start by going to geometry and doing a new design model in geometry. While this is opening up, I'm going to pull up the required geometry for the wind tunnel for project 1 from Canvas. I've got it open on my phone here, and then we're going to use the information that's given to create the wind tunnel geometry. So because we're in 2D, I'm just going to have, I'm going to look at the XY plane here. I'm going to go to sketching. I'm going to make sure units are in inches, and I'm going to make them pretty small because the geometry isn't super big. So we'll go here to line it. We're just going to create 4 horizontal lines across the x-axis here. We're also going to go ahead and dimension out these. I'm noticing, I'm seeing right here how these two lines aren't connected. You can tell because there are multiple endpoints there. So I'm actually going to go back here and I'm just going to make those lines again and just make sure that they're like end to end and sharing endpoints. Something that you're going to want to make sure that you're doing throughout because all of these lines do need to be connected. To place all the dimensions here, and I'm going to fill in the values after I've got them all dimensioned. So now that they're all there, I'm going to zoom out a little bit. I'm going to start typing in the dimensions for the different lengths. We know that this line is going to be 15, and the next one is 24, then 12, and then 42 for the last section there. That's gone ahead and put the lines out like that. We're also going to want to make sure that these lines are centered on the origin. It'll make it easier to do some calculations later. The way you do that is you just create a line that goes across all of these and then just constrain that line using the midpoint constraint to the origin like that. And that'll center that line on the origin. Then we're going to go look at the heights. The way we're going to do the heights is by creating some vertical lines. You're going to want 5 vertical lines, 1 for each of these endpoints. Then we can go to constraints, and again, midpoint constraints, and we're just going to constrain each of these lines using those endpoints as the midpoint for those lines. From here, we can go again to dimensions, and we're going to do vertical dimensions for these lines. Again, I'm just going to dimension them all out, and then I'll put the units, the actual values later. I'm actually not going to do it for the last one because for the last one, the diffuser, we're only concerned with the diffuser half angle and not the actual end height. So I'll go in here and I'll type in the different heights. For the settling chamber, we know that the height is 22, and the height is going to stay constant through the entire settling chamber. Then for the next set, we know that the height of the test section is 6. So we can actually just put the test section height as 6, just like that. And that'll give us the height of the different sections that we need. So I'm going to now move to the diffuser because we don't have the end height here. The way we're going to find that is by creating these angled lines just like this, and then a horizontal line just like this, so that we have something to angle off of. And I'm going to go here to dimensions, angle, and I'm going to create the dimensions, the angle dimensions for these. So you'll kind of see how these angles are measuring from this side. So I'll just go in, and since we want it to be 3 on the inside, we're going to put 177 on the outside. So once those lines are dimensioned the way you want them, we can actually get rid of these construction lines. So I'll go in and I'll do that. And then we can clean up some of this here. And the way I'll clean it up is by going to modify, trim, and you can kind of just trim the excess lines there. From here, we are good to start filling in the rest of the walls. So we'll just kind of make sure that, it's just connecting the dots and creating the rest of the wind tunnel. Just like that. And now we don't need any of these internal supports. So we'll go, you can actually delete all of them the way I'll do it is I'll go to trim, and I just go in and just trim all these lines that are here. So once you're done, it'll look something like this. And this is kind of the end of what the wind tunnel needs to look like. So in Design Modeler, we'll go up to Concept here, Surfaces from Sketch. For base objects, we'll just select, you can actually just select Sketch right here, apply. And then once that's done, you can click Generate and it'll fill it in for you. So this kind of ends what we need to do in the Design Modeler. You can go ahead and close the Design Modeler now and open the meshing tool. It's a little hard to see, but you know something is happening because in the bottom corner, it'll kind of tell you like updating measure, opening measure. So you know that something is actually happening. I'm going to let the measure open up fully. It's going to bring in the geometry from the Design Modeler, just like this, like you see here. And once it's in, I'm going to change it so that we're looking at it from the Z again. Now that this is in here, we're going to want to go to Mesh, and I'm going to go ahead and click Method right here. For geometry, I'm going to click down here, and I can just select the geometry that we want it to mesh, hit Apply. And then once that's in there, you can see it's got the method here. I'm going to change this method to triangles, and I'm going to let it generate. So you can see this is what it generates here. This is pretty, these are very large meshes compared to what we wanted to calculate. So we're going to have to make these meshes smaller. When you're actually doing simulations, you want these meshes to be as small as possible while still being, feasibly run in a timely manner. For the purposes of this video, I'm not going to go super small with it. I'll probably go like 0.015, something like that. Hit enter and generate that. We'll see what that looks like. And the reason for this is because I don't want to spend too much time in the video waiting for different things to load, like the meshes and different calculations and stuff. So you should go smaller than this for real calculations. For the purposes of this video, this is okay. And this will kind of get us where we need to go. Once this mesh has been generated, you can go up here to Edge Select, and we're going to start labeling these different edges. I'm going to right click this one. I'm just going to left click this one right here. Hit N on my keyboard, and then I'm going to name this one. This is the velocity inlet, so I'll name it velocity inlet. Hit OK. Same thing with this outer one. This is going to be your pressure outlet. And then everything else, I'm just going to hold down Control, select all these other walls, these other edges, hit N, and these are our walls. So I'm just going to click walls and hit OK. Once that's done, you're actually good to close the mesher here. Just want to make sure that your name selections are there and that they're named properly. And I'm going to go ahead and close the mesher now. So you can see the little lightning bolt there. That means that the mesher hasn't updated to reflect it for the rest of Workbench. So you can right click that and just click update. And it'll go in and update the mesh and kind of propagate it out so that the rest of the Workbench is able to access that mesh, which is what we're going to use in the next step. So as soon as this is done loading, we'll know it's done when we see a green check mark next to mesh. All right, so once that's done, and we can see it there, we can right click on Setup and click Edit Setup. So this is going to be 2D, obviously it knows. We'll go to Double Precision and we'll go ahead and start that up. So depending on how small you make your meshes and how complicated the geometry is, this might take more time to open up. This is one of the reasons we didn't want to go super small with the meshes, because we would be just be waiting for a long time in the video. So now, provided that you named your different edge selections properly, you should have the velocity inlet and the pressure outlet automatically kind of fulfill their boundary conditions. And you can just kind of click on them to see. If I click on it there, you can see velocity inlet is velocity inlet. Do that again with the pressure. And then if I click on a wall, it's all there. So provided that looks good. If it doesn't, you can go here to boundary conditions and you can kind of mess with the different things here. We actually are going to mess with it here. If we go to inlet and double click velocity inlet, this is where we're going to set what we want the inlet velocity to be right here at the start of the settling chamber. So for project 1, we get the velocity for the inlet. We get the test section velocity and we need to calculate the inlet velocity ourselves. The way you would do that is take the test section velocity and then divide it by the contraction ratio. Because this is 2D, the contraction ratio isn't always the most accurate for what it should be, because this is 2D. You can't really use the contraction ratio. So what I ended up doing was using the height ratio of the test section, which is here, and the start of the contraction chamber, which is here. So it ended up being like 11/3. So you divide your test section velocity by that number, and you would put that in here for velocity magnitude. Just for the sake of this video, I'm going to pick something arbitrary like 10 and hit apply. We'll close that. That's for boundary condition. For model, I'm going to go here to energy, make sure energy is turned on. And for viscous, I'm going to edit that. And I'm going to change some of the parameters here to K epsilon and enhanced wall treatment. This is based off some of the tutorials I watched, seem to provide better results. So that's all we need to do under the setup tab. We're going to go down here to solution now. We're going to go to initialization, and we're just going to go ahead and very quickly initialize it. It might not reach convergence. That's okay, because we'll still be able to go to run calculation and run it. What we'll do here is we'll go to number of iterations, and I'll just put like 150. Because we have large meshes, it shouldn't actually take 150 to converge. But you also do want to make sure that you don't have super high number, because then you'll be waiting for a long time. I click calculate, and it's going to go ahead and run the simulation. So yeah, it didn't take all 150. You can actually maybe even go in there and like take a look and see how many it took. It only took 68. If you have more meshes, it'll take longer. And then you might need to set the number of iterations higher if you're looking for a more precise result. For just the video, this is fine. When I did the project report, I actually went, I still used 150 iterations, but I just went a lot smaller with my meshes and actually ended up using all 150 iterations to get to that result. Once the simulation is run, you're going to want to go down here to results. So for project 1, you are required to find the contours for a few different things. The way you would do that is you go down to graphics and double click contours. And then to find the different contours for the things you need. For example, one of the things you need to find the contour for is the velocity inside the test section, inside the wind tunnel in general. So we'll go here to contours of velocity. Velocity magnitude is fine. Make sure that everything is selected. And we can go ahead and compute that and then save and display. And it'll go ahead and display what the velocity magnitude is at various points within the wind tunnel. So if I zoom in, you can kind of see our mesh is not very small. And so you can kind of see the mesh. If you make it the mesh size is smaller, you'll get more detailed results along the wind tunnel. But obviously you'd have to wait longer as well for the results. So this is how you find the contours. If you need to find the contours of different pressures, you click pressures, and then the pressures, static pressure, dynamic pressure, and total pressure, all things that we are asked to find the contours of are all available there. The second thing that we needed to find were the plots. The way you would do that is you would go to, again, results, plots, and XY plot. So that is what that looks like. We're going to, again, I'll just give the example of velocity. We can go velocity there. We want to find it. So for this one, we actually don't want to do it along all these things. We want to find it along the center line. That was one of the things that we were asked to do. So I'll go here to new surface, line and rake. And this is where you would create the endpoints of the center line that you wanted to use. And this is why it's important to make sure that you know where you're putting geometry. We put our geometry centered on the origin. So now that we know that the y0 and y1 are both going to be 0. And for the x and x1, all you would have to do is look at the given values and measure it out going both ways. Just to keep the video moving, I'm going to just select points with the mouse and just very quickly kind of just guess points there. And I'm going to make sure that we know that these are going to be 0 for sure. So I'm going to change those to zeros. Okay, create, close, and then we want to actually select line 4 for our XY plot. So we'll look here and we go, y is our velocity, x will be a direction vector. It will be a direction vector along line 4. So I click save and plot. That's what that plot looks like. And that's kind of what we would expect it to look like anyway. So for this, you can do the same thing for the different pressures that you're asked to find. Pressure, static pressure, dynamic pressure, total pressure is there. When you're asked to find the plots for those things going down the horizontal center of the test section, again, you're doing the same thing. You're going to go to create surface, create line, and then enter the points. In this case, it'll be 0 for the x's, and then y's will just be the top and the bottom of your test section, which has a height of like 6 inches. So you can very quickly just do the math, figure it out that way. One thing you do need to keep in mind is that we created those in inches, and this will probably require you to input it in meters. The last thing that we were asked to find in the project is the contraction constant, or the calibration constant, I'm sorry. And that requires you to have some of this data, like this plot here. Well, not this plot, but like a plot like this one for the dynamic pressure. You need to have that plot exported into Excel. The way you would do that is you would just go here, pressure. We're going to be looking at dynamic pressure, and then you just click write to file. And then when you create right here, it'll just take this data, this exact data, and export it into an XY file, which can be read by Excel. And then the calculations that you do in Excel are separate from the Fluent. So they're kind of outside the scope of this video. So that kind of goes over everything that you need to do in Fluent to get the project 1 done. Everything that else that wasn't covered in this video are just kind of like different options that need to be changed, different parameters, different plots and contours, and I kind of showed how you would get those different plots and contours. So that kind of goes over everything that you need to do for the project 1. Based on everything that you've seen here, you can go ahead and set up the 2D wind tunnel that you need, and you'd be ready for project 2, which requires you to put an object into this wind tunnel. So I'm going to go ahead and sign off. Hopefully I was able to cover everything that you needed for project 1. Have a good one.